Exponent laws. Once more time. Powers are comprised of a base and an exponent. So in this case, the base is a and the exponent is the n. Radicals are comprised of a radicand, which is the thing under the radical sign, and the index indicates what root we are talking about. Okay, so the exponent laws. Product of powers, a to the m times a to the n. Multiplying powers with the same base. What do we do with the exponents? We add them. So 3 squared times 3 to the 4th will be 3 to the... Good, I was sort of hoping we could add 2 plus 1. And 3 to the x times 3 to the 4 minus 2x will be what? So 3 to the 4 minus 1x. All right, that's product. Now we got quotient. Whoops. All right, when you divide powers with the same base, what do you do with the exponents? Subtract. So this is 6 to the 6, and this is 6 to the 8x squared minus 2x. Power of power, what do you do with the exponents? Times. 3 squared to the 4th is 3 to the 8th. 3 squared to the 4 plus x is 8 plus 2x. Power of product, a times b to the exponent m is a to the m times b to the m. 2 times 3 cubed is 2 cubed times 3 cubed, which would be equivalent to actually 6 cubed, right? And 2x to the 4th is let's do this. 2 to the 4th, x to the 4th would be 16x to the 4th. So a common mistake is just to leave the 2 by itself, right? Forget that it's 2 to the power of 4. So variables we're good at, and numbers we sometimes aren't so good at. Power of a quotient, a to the m, a over b to the m is a to the m over b to the m. Why can't b be 0? Okay, can't divide by 0. 3 over 4 cubed is 3 cubed over 4 cubed, right? That would be 27 over 64 if you're evaluating. And x over 4 cubed is x cubed over 4 cubed. Okay, same deal. Don't forget to cube the 4. 0 exponent. A to the 0 is 6 plus 1 to the 0 is x squared plus 1 to the 0 is, okay, as long as your base isn't 0. Negative exponent, a to the negative n is 1 over a to the n. 5 to the negative 2 is 1 over 5 squared, or 1 over 25. We're just leaving an exponential form for these purposes. X to the negative 2 is 1 over x squared. Fractional exponent, a to the m over n is not square root. Which root? Nth. The nth root. So the denominator is the index. So it's the nth root of a to the m, or it's the nth root of a to the m. Okay, so either one. Now, generally speaking, if you're working it out in your head, you're going to do the nth root of a, which is usually doable, and then raise that to the power of m, which is easier. So in other words, you would do the square root of 9, all cubed, but you could also do the square root of 9 cubed. So square root of 9 cubed is the square root of 729, which might not be as accessible to us as the square root of 9, which is 3 cubed, which is 27. Right? But either way works. Okay. either order. You can do the square root and then cube it, or you can cube it and then do the square root. 9x to the 3 halves would be 9 to the 3 halves, x to the 3 halves would also be the square root of 9x cubed, or the square root of 9x cubed. Or square root of 27x cubed, etc., etc. Simplify. Express answers with positive exponents only. So what's the first one? So we can break it out, right? Do it in a couple steps. Top, multiply. When you multiply, you add the exponents, p to the 14 over p to the 11. Now I'm subtracting, and we end up with p to the 3, or p cubed here. So we do numbers. Negative 48 divided by 6 is negative 8. D to the 5th over d to the negative 2. So it's going to be 5 minus negative 2, which is 5 plus 2, which is 7. Okay. And if/when I mess up, let me know, and we'll fix it. 5x to the 3 halves times negative 2x to the 5 halves is... So the numbers just get multiplied, right? There's no exponents on the numbers. Well, there is 1. So 5 times negative 2 is negative 10. X to the 8 halves which is x to the 4th. Okay. So generally, I mean, my interest is the final answer there. If you need to show extra steps to get there, it's cool. For your Canadian answer, it's negative 512. Those who are in 30-2 are now rolling their eyes. Convert each of the following to radical form. Then simplify and evaluate without using calculator. So 125 to the 1/3 is the what? Cube root of 125, which is 5. Okay, so fractional exponent. The bottom number is the root. This is a cube root. The top number is a power. If there's no power, then it's just the root, right? So 1 over 3 cube root. 64 over x squared to negative half. What do you do? So I don't like negative powers, right? But the nice thing is if you have a fraction to a negative power, you can just flip the fraction, and then the power becomes positive. Okay. And now this becomes a quotient. The 1/2 to the 64 to the half there, that's a little sloppily written. Kind of make it obvious. And we got x over 8. Express each of the following as a power. Square root of x is x to the 1/2. 5 to the 2/3, right? What power? That's up top. What root? Okay, power is 2, the root is 3. And what's this going to be? So 5x over x to the what? Okay, so the fourth root of x cubed is x to the 3/4. You have 5x over x to the 3/4. Dividing powers with the same base, you've got 1 minus 3/4, which is 1/4. So the final answer is 5x to the 1/4. Any questions? Yep. How do we get 5x to the 1/4? So you convert the fourth root of x cubed into x to the 3/4. Okay. Now you've got an x up top, which is an x to the 1. Okay. You subtract 1 minus 3/4, be 1/4. Okay. Next page. Radical expressions. Simplify and write with a rational denominator. Okay, so 8 root 2. Nothing you can do with 8 root 2 or 2 root 3, but root 18 is what? Okay. Ultimately becomes that. Root 18 is 3 root 2. So that minus 15 root 2. And now we can combine like terms. Okay? So as far as radicals go, I don't care how you get root 18 to 3 root 2. I just care that you do and that it be correct. Okay? So we're not going into the mechanics behind it. That's grade 10 stuff. Okay? 2 over 3 root 5. What do we do to rationalize that? Multiply by root 5 over root 5. So rationalizing the idea is get rid of a radical in the denominator. So multiplied by the same radical, right? So up top, we get 2 root 5, and on the bottom, we get 3 times root 5 times root 5. So root 5 times root 5 is 5, right? Don't think root 25. Just think, if I'm multiplying a radical by itself, I just drop the radical sign, right? So 3 root 5 times root 5 times root 5 is 5, times 3 is 15. Next one, what do we multiply by? 3 minus root 5 over 3 minus root 5. Okay. What's 3 minus root 5 divided by 3 minus root 5? 1. So you multiply by 1. Are you changing it? No. You're changing its form, but not its value, right? Because you're just multiplying by 1. Up top, we get what? On the bottom, we get what? Yeah, I'm going to take a couple of steps to get there, but... Okay, what do you call 3 minus root 5? What's its name? Nope. So 3 plus, so you see 3 plus root 5, you're going to write 3 minus root 5. What's the technical term for that? Conjugate. Conjugate. Good. Right. Conjugate. Looking over. New respect. So you multiply by the conjugate. Same two terms, opposite sign. What does that give you? Difference of squares. What does that give you when you go to multiply? Square the first term, 9, minus square the second term. Root 5 times root 5 is 5. 9 minus 5. Okay. Watch out for signs. Sometimes this is bigger than this. This becomes a negative. Don't leave a negative down here. Flip the signs up here. Make that positive. So no negatives in denominators. What's next? Radical equations. There, this is, see, now getting into it. This is more the Math 30-1 pace. Right? Used to the pace. This is review stuff too, right? I mean, we'll slow down on new stuff. Okay, what do we do first? What's wrong with that? It's more a form, not a... Numerically, there's nothing much wrong. Yeah, expand this, right? Where's that x? That's out here, right? So make sure it's there. that going to matter for you on the diploma? No. And let me let you write that and then interpret it the way you wrote it, which was wrong. Will that matter for you if you rewrite the diploma? Yeah, it could. So there is written on the diploma, not this one, but the next one. Okay. So it's important, though, that you write properly. Okay, now what? Next step. Okay, so isolate the radical. That's the whole idea, right? If you're going to solve a radical equation, you isolate the radical and then do what? Square both sides and then solve. And then what should you do? You should check it, okay? Because sometimes the act of squaring both sides introduces extraneous solutions. So for checking, I'm just going to do it mentally. So if I toss negative 11 over 2 in here, the 2's are going to cancel. It's 9, it's a minus. It's going to be 5 plus 11, which is 16, which is 4. 3 times 4 is 12, minus 12 is 0. It's going to work, okay? So just run, when you're doing rationals, run a quick check. Sometimes the act of squaring both sides introduces extraneous solutions. Okay, what do we do here? So the radical is isolated. We are going to square both sides. Okay, go ahead. On your paper, write down. Okay, because if you do something wrong, so I'm going to, then I'm going to tell you what's going to happen to you. Wrong. If you write this, you get 0. The question is out of 3 marks. Your first line, you do that, you get 0. I will not mark beyond that. Okay? If you square a binomial incorrectly, you get 0. Right? I do that in 20-1. It's just like, it's a 3-mark question. First line, wrong. Sorry. 0. So, what is it for reals? So if you square a binomial incorrectly, you get 0. Okay? It could be a 5-mark question. It's not going to be a 5. There's no such thing. But if it's a 3-mark question, you just zeroed yourself. I'm not looking at it. Okay? I refuse. So you know now, right? Won't be a surprise. Then we just solve this, right? So 4x squared what? Okay, and then we hope it factors. So if it does, what are we going to get? No, maybe it's a 4. Actually, okay. What do you do when you factor? What is the next thing? Immediately, you check it. Okay? I started with 2x, 2x. That's not going to work. So what do we got? 4x squared plus 8x minus 3x. Your most likely mistake in factoring is you got the signs flipped. Okay? If that happens, if I had a plus and then a minus, I would go 4x squared minus 8x plus 3x and say that's okay, I've got my signs wrong. And I get out the eraser and I fix them. Okay, so 4x squared plus 8x minus 3x is plus 5x minus 6 is 0. Okay, cool. Then answer. So x is 3/4. 4x is negative 2. Now it says verify your answer graphically, but it's just verify your answer, right? So if I throw negative 2, the root of 7 minus negative 2 is 7 plus 2 is 9. Root 9 is 3. 2 times negative 2 is negative 4 plus 1 is negative 3. So what do I say about x equals negative 2? Great. So you must show me the answer, then cross it out. Okay. You must. You don't show me the answer, it's like minus 1, even though it's just extraneous, right? So part of the whole question is recognizing, oh, that's an extraneous root.
also say you can use equal.
Yeah. Well, you could also use...
The equal and then not equal.
No, it is. The solution is x equals -2. But it's not a solution. So then you cross out the whole thing. Don't put in not equals, because really, because the line that follows from this is this: x equals -2. Then what follows that? And you cross it out. You could just write in extraneous. You could write this in the bottom. You know, the set consisting of only 3/4. So if you don't cross it out there, but you make explicit that here's my answer and it consists of only 3/4, which if you check this graphically probably works. Let's see. So what's that? It's going to be 3/2 plus 1. It should be 5/2. And that's going to be 7 minus 3/4, which is 6 1/4. And the square root of 6 1/4 is, did I say the right hand side was? 3/2 plus 1 is 5/2. 2.5. Yeah, square root of 6 1/4 is 2.5. Yep. Okay, so it works, right? But you said verify graphically. The important thing is that you verify and that you reject any extraneous solutions, okay? That's the important point. Okay, that when we solve things, sometimes they're not answers. And you must indicate that. Nothing more there. Rational. Simplify and state non-permissible values. Okay. Give it a shot. What do we do? How do we simplify this? Oh, wait. First, we're going to actually state the non-permissible value. What's a non-permissible value? 3. Okay. And when I say that, what I'm actually stating is the restriction. So 99.9% of the time, you're going to see them as restrictions. X cannot be 3. Why not? And the denominator be 0. You can't divide by 0. Right? Okay. Now, what do we do? And then, okay, one more line. Simplify. Go ahead, write the next line. I dare you. Go ahead, do it. It's fine. Right? If you're going to get it wrong, now's a good time, right? Nobody knows. Well, except you. You realize, oh, I got that wrong. That's right. Just, not messing with you. So if you didn't get that, what'd you do wrong? Okay, so what do? You look at this and you go, these two look a lot alike, except this has a positive 3 and a negative x. This has a positive x and a negative 3. So it's just flipped, right? So what do? You cross this off, and you say -1. So it's like I'm going to factor a -1 out of 3 minus x, which is then going to change the signs to -3 plus x, which is now what's on the bottom. Okay? So same two terms, but opposite signs. Not a conjugate, right? Conjugate is just you replace the plus with a minus or the minus with a plus. It's the same two terms, but if they have opposite signs, you can cross them off. You're just going to replace one of them with a -1. Okay? Make sense? There's your answer. Next one, what's the first step? Because you can't state the non-permissible values yet. What do you have to do? You've got to factor. Okay, when you are simplifying rational, you fully factor everything. So this would be 5x. It's got to be 2x minus 3, right? That's got to cancel. So when you factor the numerator, you get a 2x minus 3, and then you know the denominator's got a 2x. Then you just say, you know what, it's probably going to cancel because it's going to simplify. So I'm going to bet it's 2x minus 3. If it is, the other factor has to be x plus 5, and then I'm going to check it, right? 2x squared plus 10 minus 3 is plus 7 minus 15. Okay, what's the next step? State the restrictions. Okay, what are the restrictions? 3/2, -5. No. restrictions are only where? Where's the only place you look? Denominator. Why? Because you can't divide by 0. If the numerator is 0, can you divide into 0? Yeah, what's the result? 0. Okay. You can divide into 0, not by 0. Watch out, because I will guarantee you 100% that if part of this question is restrictions, there will be a 0 in there. All right, and then cross those off. Every time you cross something off, put a 1 in there. Who wants to get rid of the 5s? Who wants to get rid of their marks? Get rid of the 5s, get rid of the marks. So they don't cancel, right? They're not factors. You can only cancel factors top and bottom. If you want to try that, it's okay. Then what you do is just say, all right, what if x were 2? What do I end up with in this expression? And in my simplified expression, what do I get? They're the same. Okay, maybe that works. Let's try a different number than 2. Let's try -7. Yeah, okay, it still works. Okay, inductive reasoning says, it's probably right. But if you try a 2 and then you try a 2 and they're not the same, then you know. Okay, I shouldn't have done that. So back up 1 step. It's okay to want to try, but you should check. Rational equations, solve algebraically. Woohoo. What's first step? State restriction. Well, so factored form, right? So over here, we got a factor. So we're going to state restrictions first. So we factor. Now, if you're solving a rational equation, you only factor the denominator, not the numerator, right? Because the idea in solving a rational equation is get rid of the denominator. So first step here, we just state. So -3 and 0, right? Those are our restrictions. Okay, now, what's the LCD? So the LCD is the lowest common denominator, right? So it is a value that everything will go into. Y plus 3 has to go into it, so it needs a y plus 3. 2 has to go into it, so it's going to need a 2. But 5 has to go into it, so that means the 2 and the 5 are going to combine to give you a 10, right? Okay. So then what do? We multiply everything by 10y times y plus 3. We do this efficiently, saying, okay, the y plus 3s are going to cancel, and you get 2 times 10y is equal to y minus 2 times, well, I don't need a 2 or a y, so I'm going to need a 5y and a y plus 3. Sorry, I don't need the y. So 2y goes into this, leaving me with 5 times y plus 3. Plus 2, oh, sorry, remember we were getting rid of the denominator. So the 5 goes into this, leaving me with 2y times y plus 3. Okay. Now you can do this in more detail as a solution, right? I mean, you could show that I'm going to multiply each term by this, and then the next line would be this. Okay. And then you go through and you simplify. So 20y. Okay, so here we've got y minus 2 times 5y plus 15, if you like, plus 4y. Okay, so then we just expand. Again, point out any errors. Okay, so what are we going to end up with? 9y squared plus 17. It's right.
zero state restriction?
They're up top. Can't be -3 or 0. Now, you compare your answer to the restrictions. And you say, well, my answer does not include one of the restrictions, so those are both legitimate and correct answers. You could verify graphically if you like. And you could graph it and check that that is those two solutions, okay? But that's why we do restrictions, right? Because we have to check our answer. Because when you're solving a rational equation, you're doing stuff. You're multiplying by denominators. Things disappear, okay? So maybe things that, aren't valid work their way through. Okay? And you end up with the solution, which is a restriction. Whoops, that's not the key to use. Okay, let's pop this back down. Ramp up a little from 30-2. All right, everybody good? I'm going to wipe this out in a second. Yep.
When you factored out the 3, like, did it just disappear?
So what I didn't factor, I divided both sides by 3. Okay, so here's the deal. When you're solving an equation, right, so it's equal to 0. Anytime we solve a quadratic equation, it has to be equal to 0. If it's not equal to 0, then your mark will be equal to 0, right, because you can't solve it otherwise. And you'll waste 10 minutes. Okay, so it has to be equal to 0. If I divide both sides by 3, I maintain equality, right? So those two graphs are not the same graph, right? Because one of them is obviously vertically stretched by more than the other one. But they have the same x-intercepts. And that's what we're doing when we're solving, finding the x-intercepts. Now, if you're in calculus, right, and this is a function, y equals 9y squared minus 3y minus 30, you can factor out the 3, but you can't make it disappear, right? So you go y equals 3 bracket, blah, blah, blah. Okay, so you have to keep that, right? If it's a function, not an equation. This is an equation. We divide both sides. Okay, good. All right, need to clear some space to do the next one. So start on the next one. At least do some factoring. When I get back up there. Okay, next line. Factor denominators. Not plural. Factor the denominator. State restrictions. Okay, so step 1, factor the denominator. Step 2, state the restrictions. Then we'll solve. Do not put an equal sign out here because there's one in here. Okay, so we put an equal sign there when we're like simplifying an expression to say this expression is equal to this, is equal to this, is equal to this. This is an equation, so we don't put an equal. There is an equal sign. What says this line is the same as this line is the same as this line. Right? Simplifying an expression, you just have an expression. There's no equal sign. You put an equals at the front. Make sure that they're there. Now, this isn't hard to factor because it just has to be those two numbers from there. Otherwise, the expression is going to be overly complicated, and we're not going there. Restriction. Okay, -3 and -1. I haven't looked at the answer. I bet you dollars to donuts we're going to hit one of the restrictions. Comes out as an answer because it didn't in the first one, so it has to in the second one. No, it doesn't have to. Okay, LCD is multiply each term by the lowest common denominator. You can do that showing it and doing the crossing out. I don't, so I'm just doing this. But eventually, either on the next line or 2 lines down, this is what you end up with, hopefully. And then you solve, right? This point is just grinding away. Right? That's half this course. It's just grinding away. anyway, doing the algebra is doing the algebra. But just set it up. But it's doing it correctly. That's the important thing. Right? Getting enough practice so that something like this just becomes, tests should be boring. Right? Like, seriously, it should be like, done this a million times. Oh yeah, there's one of those things that cancels out. I could have expected that. Right? You don't want tests to be exciting. If tests are exciting, then it's like, I've got a clue. I don't know what to do here. Now, one question or two questions exciting, not so bad. Most of it should be boring. Maybe this didn't have a restriction as an answer. Who knew? Wouldn't have been surprised. It is right, or my key is wrong. It's like either my key is wrong, which is entirely possible. Okay, any questions? So remember, all this stuff is or will be up in Schoology. Right, for you to sit down at your leisure, go through, right? So if you didn't understand something, then to come in on, Henry's or Wise time or whatever to just ask if there's anything. It's like, I don't know what's going on here. Like, what am I doing wrong? Stuff like that. So get everything straightened out. The reciprocal of a function. So the graph y equals 1 over f of x. Point xy that lies on the graph y equals f of x is transformed to the point what? One over y. On the graph of y equals 1 over f of x. All this is in your 20-1 notes. If y equals f of x is a continuous function, then y equals 1 over f of x will have a vertical asymptote wherever. So the original function is continuous. Something like x squared, right? Okay. So when are we going to get an asymptote? So if I want to go 1 over f of x, I can't do 1 over 0. So we're going to have an asymptote wherever y equals 0, right? Or f of x equals 0. So whenever that happens, so basically it says, whenever the original function has a 0, the reciprocal function is going to have a vertical asymptote, right? The invariant points are the points where the blank coordinates are more detail. Okay, so if I go 1 over something and I'm going to end up with the exact same value, what was it? 1 over 1. Or negative 1. So, where the y coordinates are 1 or negative 1. Okay? So if y is equal to 1, 1 over y is equal to 1. It's invariant. Right? Invariant is going to become a very large portion of your vocabulary / life in Math 30-1. Invariant points. Okay? Points which do not change. Okay? So we'll work our way through transformations. We may have invariant points. What is the conditions that required? So for a reciprocal function, the y coordinates are 1 or negative 1. So the reciprocal, 1 over 1 is 1. 1 over negative 1 is negative 1. And my board is still acting up. Whoa. Okay, the graph of y equals fx is shown below. Sketch the graph of the reciprocal. Okay, so what's the first thing that we said was where the original function is equal to 0, we are going to have a vertical asymptote. So, here's a 0. There's a vertical asymptote. Okay, under the steps below, see the steps there? So number 1, draw vertical asymptotes through the zeros, or the x-intercepts, right, of y equals f of x. Okay, so I'm not going to write these down. I'm going to say them. You're going to write them down now. So step 1, draw vertical asymptotes through the zeros, or x-intercept of y equals f of x. Okay, of the original function. Okay, draw vertical asymptotes through the zeros of the original function. Okay, then the next thing we said was, so after we did the asymptote thing, we said we have what? Invariant points. Remember the word invariant. You can see it a lot. Invariant points where? What? 1 and -1, where y equals 1. So what I'm going to do is just go along the line where y equals 1 and where y equals -1. And I'm going to mark the invariant points. Okay, so there's my invariant points, right? Okay, so that's step 2. Under step 2, write. Plot the invariant points. Bracket y equals plus or minus 1. Okay, so plot the invariant points. 11 or 12. Okay. No, they're next. So I can bring it down anytime. Perfect. I was surprised. Exactly. Yeah, I know. Perfect. Thank you. Woohoo! Books! We got books. Okay, what next? So the next thing is, you're graphing y equals 1 over f of x. So sometimes for nice values of y, you can get values of x. But there's also key points. So here is a key point, right? That's the minimum, which is -8. What's the reciprocal of -8? -1/8. So we're going to plot key points. So this is step number 3. Plot the reciprocal. So step number 3. Plot the reciprocal of any max/min, max or min, right? Or other key point. Number 3, plot the reciprocal of any max/min or other key point. Next, draw the function. Don't write that down. So what we're going to write down is this. So, we look at the curve, right? And we say, okay, this point is invariant. These guys are going up, right? So as y equals f of x gets really big, what happens to 1 over f of x? It gets really small. Does it reach 0? No. So what we're going to do is draw that. So you can write down, as y equals f of x gets larger, 1 over f of x gets smaller, towards 0 but not 0. Okay, if you want to write that in, but it just gets smaller. Okay, so as y equals f of x gets larger, 1 over f of x gets smaller. Okay, tending towards 0. Now on this side, so here we're going from 1, now I'm going to the left, this way. We're going from 1 down to 0. So as f of x gets smaller, a half, a quarter, a tenth, what does the reciprocal do? It gets larger, right? Reciprocal of a half is 2. Reciprocal of a quarter is 4. The reciprocal of 1/10 is 10. The reciprocal of 1/1,000,000th, which we're going to hit, is 1 billion. So what happens to the curve? It's going to climb up. going to get larger there. Okay, so you can write down under number 4, as y equals f of x gets smaller, 1 over f of x gets larger. And if you want, you could write smaller as it's going to 0, because as it gets smaller, it's going to go down to 0. Then 1 over f of x gets larger, right? But we can't hit 0, right? We're not allowed to do 1 over 0, which is why it's basically climbing the asymptote. It doesn't really do that, right? I mean, it climbs up, it approaches that asymptote line. It's not going to touch it or cut through it. So, same deal is going to happen on this side, right? Okay, so as we go to the left, those values are getting larger. The reciprocal gets smaller, goes down to 0, never hits 0, doesn't go negative. Those are positive values on the extreme left. Same deal as we go from 1 down to 0, smaller f of x values, larger 1 over f of x. We climb up. Kind of the same thing goes on here. So this is going from negative 1 down to 0. It's getting smaller. So these guys are going to get larger, but larger negative values. Right? Same thing over here. These guys are going from negative 1 down to 0. They're getting to be very small negative values. Their reciprocal will be very large negative values. What happens in between? Well, we're going to get values that are going to do that. Not that there, that's ugly. I'm not redrawing it, you just got to kind of draw it smooth. So all that happens in there, well, these are actual values, right? It's going to be a negative a quarter here, negative a third, negative a half, right? Negative 1/7, negative 1/8, negative 1/7, negative 1/6, negative 1/5, right? This just does that little in there. So step 5, draw a smooth curve. Do not cross the asymptotes. Okay. Do not cross the asymptotes. Okay. There's actually also in here a horizontal asymptote, right? So there is a horizontal asymptote as well. Note, if you're in tight, you can cross a horizontal asymptote. Horizontal asymptotes are really what's going on way out there, not what's happening in here. It's like what happens when x gets up to 100 trillion, or 10 times that, or 100 trillion times 100 trillion. What's happening at the extreme left or right of the graph? That's a horizontal asymptote. Okay. Vertical asymptote you can't cross. Okay. Never, ever. A horizontal asymptote can. Now in this case it isn't, but some of you are going to go on and do calculus, and it will. Then you're going to say, but you see you can't cross. No, you can cross the horizontal asymptote. Because we don't care about what's happening here. We care about the extremes for horizontal asymptotes. Okay. What's next? Trigonometry. All right. Push, push. 45, 45, 90-degree triangle shown. Determine the exact value of the length of the hypotenuse. What is the exact value of the length of this hypotenuse? Root 2. Okay, cuts. The square root of 1 squared plus 1 squared, right? So that's where the root 2 comes from. What is the sine of 45? 1 over root 2. What's a better way to say 1 over root 2? Root 2 over 2, right? We have to rationalize the denominator. Now, there are times when we will look at the sine of 45 and say, hey, at this point, it's better to use 1 over root 2 than it is to use root 2 over 2. Usually it's when we're dividing, right? If I'm going to divide by the sine of 45, I want to divide by 1 over root 2 because I'm just going to flip it and multiply, and then it's just root 2. If I divide by root 2 over 2, it's going to flip. I'm going to have to re-rationalize the denominator. Okay? So it's either value. What's cos 45? 1 over root 2 or root 2 over 2. You are going to know these angles very well. Okay? Well, yes, you are going to know them. What's tan of 45?
1.
1. Okay. So you need to know the sine, cos, and tan of 30, 60, 45, 90, etc., all the way around the circle. Only you're actually going to do it in radians, which you don't know what they are now, but by the end of the trig unit, you're not going to want to use degrees anyways, but you have to. But you're going to prefer radians. Whatever those things are, you're going to say, I prefer these. The 30, 60, 90 triangle. So what we do is we say, I'm going to make a 30, 60, 90 triangle, but I'm going to take it from an equilateral triangle, which is 60, 60, 60, right? Because if it's equilateral, then I know that this side here is how long? 2, right? Every side is 2. So this is 2. This is 1. What's y? Root 3. Okay, so square root of 2 squared minus 1 squared, which is the root of 4 minus 1, which is root 3. Okay. Remember, it's all review. All right, what's the sine of 30? 1 over 2. Sine is defined as opposite over adjacent. Right? So 1 over 2. What's the sine of 60? What's the cos of 30? What's the cos of 60? Okay. What's the tan of 30? 1 over root 3, or, again, depending on what we're doing, sometimes this is better. If you're going to divide by the tan of 30, don't use this. Use this. You don't have any rationalization to do. Use this. You got to rationalize. And what's the tan of 60? Plain old root 3. You're going to know all these numbers. You have to know all these numbers. It's not optional. It's like you have to. What's next? Determine the exact values. What did I say? If I ask for exact value, you give me decimals, what's going to happen? You're going to lose. If all you give me is decimals, you're just going to lose the mark. If you give me the exact value and then the decimal, you're going to lose a half mark. Okay? You square a binomial wrong, you lose all the marks. It asks for exact value, you throw in decimals, you can't read, you don't understand what it's asking for, you lose a half mark. Okay? Seriously. All right. Determine the exact value of each of the indicated sides. Exact value. So, what do we got? 30 degrees. What do we know? Well, in a right angle triangle, we know that sine theta is opposite over hypotenuse, right? So the sine of 30 degrees is going to be what? It's going to be y over 12, right? Because y is opposite 30, 12 is hypotenuse. But what is the sine of 30 degrees? 1/2. So what's y? Y is 6. It's a nice exact value because it's just a number, right? It's a whole number. What are we going to do to get x? Use the cos. So the cosine of an angle in a right angle triangle is defined as adjacent over hypotenuse. So the cosine of 30 degrees is equal to what? X over 12. Well, what is the cos of 30 degrees? Root 3 over 2. So root 3 over 2 is equal to x over 12. So what's x equal to? Okay, so the exact value is 6 root 3. Okay, you just multiply both sides by 12, right? 12 root 3 over 2, which is 6 root 3. I don't need to, but yeah, it's not going to hurt if I do that. Questions? Comments? Concerns? All right, x. What's x? Name x. Name 20. What's 20? Give it a name. Hypotenuse. Then what's x? adjacent. Which ratio? What's the secret to math? Formula, substitution, answer. So you show me the formula. I know you're using the right formula. You've identified there's the cosine ratio. You're telling me what it is. It's a right angle triangle. I can use this. And then you say, okay, so now I'm going to substitute. So the cos of 45 degrees is equal to x over 20. I could say x is 20 cos 45. Which cos 45 do I want to use? 1 over root 2 or root 2 over 2? Root 2 over 2, right? Because I want to have to rationalize. So 10 root 2. If there's units, throw in units. Okay? It's going to be really important for your younger siblings. I got to get you trained well so when you're helping somebody younger than you, because they're going to have written response, that you're going to make sure you put units down, because they will lose marks. They never used to on diplomas, but they will now. Use your knowledge of special angles to determine the values of x and y. And since cos 45 is the same as sine 45, or since it's a 45 blah blah, it's an isosceles right triangle, x and y must be the same. So then x is also root 2 over 2. That's not the only way you could have done this. You could have used Pythagorean theorem. X squared plus y squared is equal to 1 squared, but x squared is y. So 2x squared is equal to 1, x squared is 1/2, x is plus or minus. Well, but it's a triangle, so we just go with the positive. 1 over root 2 or root 2 over 2. That works there. It's not going to work for the 30 and the 60, right? We do have to use sine and cosine for those. So, what do we say? Sine 30 is equal to y over 1. So y is equal to sine 30. Y is 1/2. Cos 30 is x over 1. So cos 30 is just x. Cos 30 is root 3 over 2. X equals root 3 over 2. Cos 30 degrees is x over 1. X is equal to the cosine of 30 degrees. X is equal to root 3 over 2. Sure, we hit trig, you're going to know these. If you knew them beforehand, it's not a bad thing. And then, same deal is going to happen here, right? So the sine of 60 degrees is equal to y over 1. Y is equal to sine 60. Y is root 3 over 2. And cos of 60 degrees is x over 1. X is equal to cos 60 degrees. X is 1/2. You notice that the sine of 30 degrees is equal to the cos of 60 degrees and vice versa. Right? Notice that the sine of 60 degrees is equal to the cos of 30. Coincidence? You know what cos means? You know what the co and cosine is? Complementary. So cosine means the sine of the complementary angle. So cosine of 60 degrees is the sine of the complementary angle, which is 30, right? Complementary adds up to 90. So cosine of 60 degrees is the sine of 30 degrees. Cos of 60 is sine 30. cosine of 30 is the sine of the complementary angle sine of 60. So for this whole unit circle thing you were exposed to in 20, you're going to have to memorize. I know one fact. I know the sine of 30 degrees is a half. That's all I need to know to do the entire thing. But that's a long way away. Before we reach trig, there's a lot more to do. State the exact value of each of the following trig ratios. Remember all the way back to Math 20? Weeks ago? Okay, months ago. Some of you are fresh out of 20, right? So this is like, oh, thank God, right? Some of you, it's like, I did 20-1 like in the first semester of last year. I remember nothing. But it'll come back to you, trust me. Okay, so the sine of 150 degrees. So 150 degrees is in quadrant 2. So here's what we're going to use. We're going to use reference angles and the cast rule. So here's the cast rule. Okay. So the cast rule tells you in which quadrant a particular ratio is positive. So instead of the cast rule, you could use you start in quadrant 1. See, cast rule is weird. It just starts in quadrant 4 and like Y. So you can start in quadrant 1, ASTC. All science teachers combust. You just got to heat them up to the right point. You should just burst into flame. Or add sugar to coffee. Shouldn't do that. Sugar's bad for you. I haven't got to the point of cutting it out yet. Or anything you want to remember that, right? So you need to know the cast rule. Reference angles are the positive acute angle between the x-axis and the terminal arm. So 150 degrees is going to look like this. There's 150 degrees. This guy here is 30 degrees, right? That's the reference angle. So the sine of 150, it's in quadrant 2. In quadrant 2, the sine is positive. The sine of 150 is equal to the sine of 30 degrees, which is 1/2, right? It's positive, and any angle has the exact same value for sine, cos, or tan, but it may have a different polarity. I'm going to use polarity instead of sine, otherwise we're throwing signs around, S-I-G-N signs. So it may have a different polarity, right? Could be positive, could be negative. That's what the cast rule is going to tell us. So we're going to kind of graph the thing or figure out what's my reference angle, what quadrant am I in. The reference angle is going to give me, I can use this ratio, right? The numbers we already did, 30, 45, 60, 90, which is all you ever need. Okay, so cos of 135 degrees. So 135 degrees is over here. The reference angle is 45 degrees. So it's the negative cosine of 45 degrees. So cos 135 and cos 45 has the same value. But 135 is in quadrant 2. In quadrant 2, only the sine ratio is positive. So cosine is negative. So the cos of 135 is the negative cosine of 45 degrees, which is negative root 2 over 2. Tan of 240. Where's 240? So 240 is in quadrant 3, right? 0, 90, 180, 270, etc. The reference angle is 60 degrees. In quadrant 3, what do we know about the tangent? Positive. So tan 240 is equal to the tan of 60 degrees. Tangents always require plot, which is root 3. The sine of 225. Oh, negative 225. So where's negative 225? So I'm going to rotate. There's negative 90, negative 180. So there's negative 225 degrees. Okay. My reference angle, which is in here, is 45 degrees. It's a sine. It's in quadrant 2. It's positive. So that's equal to sine 45 degrees, which is root 2 over 2. Now, you know, we kind of did this in 20-1, which is a good thing, and we are going to do the heck out of this in 30-1, right? So this just becomes an expectation, right? I ask you for the sine of 150, I get a half. I don't care how you do it. Okay? I will show you numerous ways to do it. The internet can show you 160,000 more ways to do it, right? You just find something that works for you, but you have to know all of these, right? And this is how I know these, right? It's like I'm not bothering with 150. I just need to know where it is and which ratio. So cos of negative 270. Well, negative 270 degrees starts here, 90, 180, 270. That's negative 270 degrees. That would be the same as the cos of 90 degrees. Okay, what's the cosine of 90? This you have to know, right? It's 0. The tan of negative 90, there's negative 90 down there, which will be the same as the tan of 270 degrees. Tan of 270 is undefined. Undefined. Okay. Don't worry, we aren't going to spend a lot, and by a lot in math 3, that's what I mean A class. We're going to spend a lot of time, A class, maybe 2, on doing this. Okay. All right. Is there more, or are we done? Oh. Woohoo! Wait, there's still 2 minutes. No. So, is there any homework on this? Oh yeah, exercise. You may now do, on your by permission, you may now go ahead and do all of the exercise. So this weekend, run through all the exercises, right? And then, you have a period free spare, you can transfer to my Math 30-2 class. Or you just rearrange your timetable. No. If I want to stay at least, seriously, if at some point you decide this is not it, it's not going to happen, and you do want to move to 30-2, as long as you do it before April, so I can take you at the midterm of 30-2, you'll be fine. Right? You can get all caught up and get through the rest of the course. Okay. But don't let it get that far. You know, if you're averaging 27% after the first 3 units, you're done. Okay, it's time to move. Go.